Okay, so last video we got introduced to object-oriented programming and started talking a little bit about objects and a little bit about classes and the role that they play together. We're going to dive in today, getting really a little bit deeper into classes and the structure of a class. So we've used classes before, but just barely, not really. We've been using Java, an object-oriented programming language, as if it were a functional programming language, right? We were just really doing like a lot of math calculations effectively. A class's main function is to serve as the template or blueprint from which objects are created. Last video I gave this example talking about cookie cutters being classes and the actual cookies being objects. Ultimately, a class is responsible for defining the state and behaviors of an object. There's going to be 4 parts to the class itself. We're going to have a header. We're going to have instance variables, otherwise known as fields or instance fields. This isn't the first time we've seen this word instance, right? In our last video, I talked about how the word object and instance are interchangeable. So you could almost think of these as object variables or object fields. Likewise, the class is going to define constructors and methods. Here is a little bit of that in code, and we're going to break these things apart and talk about them more in detail. But we see our class header at the top, followed by instance variables, then our constructor, and then our methods. So let's talk about the class header. This is probably one of the main sections we're really familiar with. The header of a class defines the name of the class as well as its access level. Here we see public class dog. Right? That's the main thing that we've used class headers for, is to kind of name our file. But additionally, one responsibility of a class header is to set the access level. As you might imagine, there's other access levels that are possible. Right? Everything we've written has been public and will continue to be public, but you could have a private class. You could have a protected class. There's other options out there. So we have the access level being set as well as the name of the class. While it is possible to have a private or protected class in Java, all the classes we will create will be public. That brings us to our instance variables. Instance variables, or fields, are used to represent an object's state. Right? We talked about how classes, one of their main things is to set the state of the object. Here we see private string breed, private string fur color. Instance variables are going to be an awful lot like normal variables, with one syntactical addition, an access modifier. I am at some point going to ask you the question, how do instance variables differ from what we will now refer to as local variables? All the variables we have made thus far are technically local variables. We're getting introduced to instance variables. So a question you're going to see is, how do instance variables differ from local variables? And almost every student, without missing a beat, is going to say they're private. Well, all the ones that we make are going to be private. But what I'm looking for is for you to say they have an access modifier, right? While it is possible to have public instance variables, all of ours are going to be private, and there's other options out there. In fact, in this class, AP Computer Science A, you'll have free response questions on the AP exam, and those variables, the instance variables, whenever you write them, they need to be private. You'll actually lose points if you make them public. Okay? But notice that these things are very similar to our local variables. We actually have a data type and then a variable name. Here I'm declaring a variable, an instance variable, a string for breed. Here I'm declaring a string for fur color, a double for weight. So these variables, these instance variables, they have a data type and a variable name. What's different is they have an access modifier. Ultimately, these instance variables are used to store data about the individual objects. It's also important to note the scope of these variables. We saw a snippet earlier of a class. I'm actually going to bring up IntelliJ, where I have this kind of laid out, right? Anatomy of a class. We see our class header. We then see a brace indicating the body of the class, and then we see our instance variables. What I want you to note is the body that these are declared in. All of our local variables have been in the body of methods in the past, right? What body are these in? These are in the body of the class, right? The class starts here, and then boom, my instance variables. So they are in the body of the class. What that means is their scope is going to overlap into these inner bodies. We have our constructor, which we're going to talk about in just a moment. We have methods down here. And notice that these instance variables are going to overlap into these things, right? Here in the constructor, I'm referencing breed. I'm telling breed to be Vizsla. Well, what is breed? Breed is the instance variable that I declared up here. So the scope of this thing starts in the body of the class. It overlaps into these inner bodies, and the scope doesn't end until down here. So the scope is expanded for these things as opposed to our local variables. So instance variables are declared in the body of the class, and thus they can be accessed anywhere in the class. Each object will have its own set of instance variables. For example, if we construct two different dog objects, each dog will have a breed, fur color, weight, etc. So in the last video, I talked about how you can create a string and then you create this double and then you wrap them up and they kind of stay together. That's what we're talking about here. Every time I make a dog, it will start out with these 5 variables. It'll have these 5 variables, right? I create a dog, and it's going to have a breed, a fur color, a weight, a position, and then an indicator saying if it's barking or not. And then I'm going to wrap that up, and I'm going to keep those things associated with themselves. Well, if I come along and create another dog with a breed, a fur color, a weight, a position, and barking, and then wrap those up, that's the idea here. Keep in mind, objects are just a collection of data, and each dog we create is going to basically have its own personal copy of these variables. Those 5 variables get created, they get wrapped up, they belong to that dog. Maybe the 5 variables get created over here with a different dog, and they get wrapped up, and they're associated with that dog. That brings us to our constructor. The constructor is used to construct or instantiate an object. Instantiate, that's a weird word. It's coming from that word we were talking about earlier, instance, right? The word instance and object are interchangeable. We're talking about objects here. Like, this is the process of creating an object. Ultimately, the main purpose of the constructor is to set the initial state of an object by initializing the instance variables. I have this memorized, and I pound it into my students that they need to know this. I wanted to ask repeatedly, what is the main purpose of the constructor? And that is to set the initial state of the object by initializing the instance variables. Initializing, what are we talking about? Setting values. Right? These instance variables are declared in the body of the class, but they don't have a value. Right? I'm creating these containers, but there's nothing in them. That's the purpose of the constructor. Right? The constructor is to give them their initial values. As we can see, or as we're going to see, with just like any other variable, these values can change over time, but the constructor is giving them their starting values. The header of this constructor is going to be strikingly similar to that of a method header, right? We see an access modifier, we see some type of name, we then see some parentheses. Okay, this looks different from, say, the class header because of these parentheses. That's a big striking difference. And so my mind is, oh, this is starting to look like a method. This looks just like a method, actually. However, constructors do not return values, hence there is no return type, right? You see this gap here where there's effectively nothing. If we go and look at some methods, you have to recall that a method has an access modifier, then we see a return type, then we see the method name, and there's those parentheses. This particular method doesn't take any parameters or arguments. These don't take any parameters or arguments either, but they have return types. Our constructor, on the other hand, while having those parentheses, kind of indicating that it can take parameters or arguments, it doesn't have a return type at all. So that's one key difference on how it differs from a method. More importantly, the name of the constructor must match the name of the class, right? This is a constructor, and here's my class header. Notice that the name of the constructor matches the name of the class as defined by our class header. Do you think capitalization matters? Let's see. If I was to change this to lowercase dog, ooh, yeah, we see squiggly, red squiggly, IntelliJ, not happy. right? This starts to look like a method, except there's no return type, so it must be a constructor. And for this constructor to match our work, it needs to have the same name as the class header, and capitalization matters. While instance variables are used to store data about the object's state, methods are used to simulate the object's behaviors. Right? We talked about a class is supposed to define the state, it's supposed to define the behaviors. State being attributes or characteristics. Right? Something like a breed. This is a single attribute. Fur color, that's a single attribute. Weight, single attribute. Collectively, they make up the state. The other thing a class does is define behaviors, and these are represented with methods. Right? Methods are used to simulate an object's behaviors. Methods often simulate behavior by changing the state. Right? How do we simulate a dog sleeping or eating or running? Well, we modify the behavior. Right? Those behaviors, they're represented by instance variables, and like any other variable, they can change over time. It's important to note that these method headers do not contain the static modifier. Static will be explained at a later date. At a later date. For now, we will exclude static from the methods in our classes. So we're getting into object-oriented programming. Static is effectively the opposite of that. Right? All the programs we've been writing, we've basically been ignoring object-oriented programming. Even though we're using an object-oriented programming language, we've been ignoring those aspects. So all of our stuff thus far has been static. It's a little bit more complicated than that, but just keep in mind that static basically represents functional or procedural programming languages, and object-oriented programming is the opposite of that. It's important to note that our dog class does not contain a main method. Right? If I go back to this thing, there's no main method in here. I have these methods which represent behaviors like sit, run, and bark, and the way they end up simulating that is by modifying the instance variables, which are part of the state. Right? Position, what's position? Oh, that's this thing up here. It's this instance variable, position, whose scope overlaps into these bodies and doesn't stop till down here. Well, I can modify it in these inner bodies. These methods are able to refer to position because it exists inside of this scope. And what's it doing? We're changing the position. When I call the sit method, we're going to change position to sitting. What was I talking about? There's no main method. It's important to note that we don't have a main method. Ideally, a class should represent one concept and thus fulfill only one purpose. With object-oriented programming, we're trying to create code that is so generically good that I can take it from one program and reuse it in another one. If I were to plug in a main method, I'm locked in. That class, I have to basically go in and edit the source code from that point on if I want to reuse it. However, what we do in practice is separate those things. Right? I want my dog class to be used to represent dog objects, and that's it. I don't want it to actually execute anything. Instead, what we do is that we create a separate class whose main purpose is to drive or execute the program. The whole reason being is that while in this class we're using like the main method in order to execute our programs, in practice maybe you use some type of graphic user interface, a GUI. And so you want to like create your dog, and then maybe you create this other class that has a main method in it that tests your dog program. But when you go to deploy the code, you're actually using some type of graphic user interface. Well, notice that my main method is in this class, my graphic user interface is in this class, but both are using the dog class. That's the idea. If I was to plug the main method into my dog class, it makes it a lot harder to come in and try to use a GUI. I have to basically go in and extract the main method stuff out of there. So the purpose of a class that has a main method is that they're trying to drive or execute the program. We have a special name for a class that drives or executes the program. We call that a driver. I'll call it a driver almost always, but I've also seen the term runner to refer to such a class. So let's recap. How many parts does a class have? Our answer here is 4, but can you name all 4? we're going to have a class header, instance variables, constructors, methods. The syntax of an instance variable is different from other variables in that it has this. I told you I was going to ask this question, and almost every student is going to go private. What I want you to say is an access modifier. While we are going to use private almost always, I'm going to show you public instance variables and try to explain to you why you don't want them. And then we're going to go back to using private. What I want you to recognize is that you could use something other than private. It could be public or protected. So instance variables, one way that they differ from local variables is that they have an access modifier. Instance variables are used to represent an object's state. Right? State is attributes, characteristics. We talked about a dog having attributes like fur color or weight, breed. Right? That's a single attribute, but collectively they make up the state. Instance variables are declared in the body of a class. What is the main purpose of a constructor? I told you I would ask you this. That is to set the initial state of an object by initializing the instance variables. Word for word. It's up here in the noggin, right? I'm going to ask you this over and over and over again. What is the purpose of a constructor? And I want this to be your response every single time. The name of a constructor must match the name of the class as defined in the class header. Right? We saw that with our code. Dog with a capital D is the name of the class. In the constructor, it's dog with a capital D. Methods are used to represent an object's behaviors. A class whose main purpose is to execute the program is known as a driver or runner. I'm almost exclusively going to use the phrase driver. And that is it for this introduction to a class and kind of explaining the purpose of a class. In our next lesson or video, we're actually going to start making objects. I'll see you then.